Hey guys, so welcome to part two of today's lecture. So basically I'm trying to break up the lectures into smaller parts because it's just easier on uploads in terms of bandwidth. Otherwise it takes hours to load things up. So I apologize for little bite-sized pieces. But on the other hand, it's probably just as easy for you guys because you don't have to hear me drone on for hours on end. So anyway, um, have a cup of coffee between, two parts of the lecture, I guess. So if you will recall from the first part of the lecture, our goal was to figure out whether there were, so there are a number of these competing kind of models of understanding the causes of civil conflict. And what they do is they give out testable hypotheses. And what that basically means is that some variables are going to be associated with some of the models or one of the models and not with others. You see what I mean? And so what we want to do is identify those variables that actually help us understand conflict. And if you can identify some subset of variables that can help identify or predict conflict, we can say, you know what? If these variables predict conflict, then the theory that came up with these variables is probably a better way to predict conflict than some of the other theories. And that's kind of a way in which we can separate out different theories and identify the ones which are more plausible and better at explaining conflict, right? Or civil conflict in this particular case. So that's what we start off trying to do. But to do that, you got to collect a whole bunch of data, right? You got to collect a whole bunch of variables from that kind of cover everything that everybody's ever talked about. And that's what we did. And so you will notice that in the data set, our target, this is predictive, right? So we want to target, we want to figure out an incidence of political or ethnic war, if any one of these four things happen, right? Incidence of political or ethnic war, adverse regime changes, genocide or politicide, in any period 5 years out. So if any 1 year, 5 years out, if that happens, we'll say, well, there's been conflict, okay? So that's sort of what we want to help predict. And so for predictive variables, we have a whole bunch of all these different kinds of variables that really kind of, it's sort of the usual suspects in the literature. So right now, I have to take my word for it, I guess. But it really is a compendium of an impressively large data set that collects everything under the sun. And we have data from the early 1900s till about 2014. That's kind of when we wrote the book. So it's a pretty substantial data set. And so you notice that it has measures of discontent, institutional quality, how good of a bureaucracy they have, whether they have good, free market-oriented economies or not, their legislative processes. So, how is the executive selected? Are they really elected? Are they elected by, kind of a smaller group? So there's all kind of variations here. How independent is the legislature? Is it like like for example, I think, I don't know if you've seen the news or not, but Viktor Orban in Hungary has basically said that he's going to rule by edict. And he's emperor of, or king of, maybe not emperor, but king of Hungary right now. And parliament basically is just a cipher, right? It's pointless. So, and then, there are these polity 4 data sets, which basically say, are you a democracy or an autocracy? How much of a democracy are you? And does your regime, is it like durable, or is it like, like a banana republic, you're kind of changing governments every other day. And then, of course, you have the usual economic variables: per capita GDP, trade, terms of trade, all kinds of stuff. Things like electricity generation, the role of agriculture, then communication, roads, phones per capita, those kinds of things. Education, how well educated is your population? What's the percentage of young men versus, the rest of the population? How much, things like dependency ratios. So which is basically, this ends up being important, so I just want to mention this. So things like, the dependency ratio is basically the ratio between the working age population and older and younger people, the ones who are not working. So a higher dependency ratio basically means that you have a small percentage of the population supporting who are productive, and they're supporting kind of a larger proportion of the non-productive kind of population. And then what we do is, one of the things you'll notice that some of these variables are very, very similar, right? You know, and so if you look at, you know, democracy, for example, well, a democracy would have some correlation with how the executive is selected, whether the legislature is independent or not, right? So we do something called an exploratory factor analysis. This is part of something called pre-processing the data, by the way, in machine learning terms. So we do an EFA, and what the EFA really does, it tries to find variables that sort of hang together. Okay, that's kind of one way of kind of thinking about it. And so here's what we find. So you'll notice here that if you look at the first column here, democracy, right? So what kind of hangs together? Well, democratic accountability, polity too, which is kind of how much of a democracy you are, executive years in office, whether the legislative is competitive or not, whether there is electoral competition, which means that, you know, people are competing for votes, right? Which is kind of a hallmark of a democracy. Whether the legislature is fractionalized or not. So, you know, you'd expect legislatures to be kind of fractionalized and more fractionalized, or at least have some degree of fractionalization when you have democracies, right? Whether there are checks on power or not, which is kind of a checks and balances, a key feature of a democracy. So anyway, so you find all these different components of that sort of hang together, and we call that, well, that's a measure of democracy. Similarly, we look at transparency. So transparency, notice, you know, what some of the things here, or what tends to hang together. So investment profile, basically how much of a market-oriented economy you are. So a country that has property rights protection and contract enforcement, well, that would score higher in investment profile. Low corruption, whether there's democratic accountability or not, whether the bureaucrats are corrupt or not, whether the regime is durable or not. So by the way, notice this hangs together, right? Because if you have, you know, so for a good investment profile, economic policies have to be consistent. You can't say one day that, you know what, I'm going to let you make a profit, and then tomorrow say, well, you know what, I'm going to nationalize your company, right? So those kinds of things kind of go together. So there's transparency, and then there's credibility, which is basically you have kind of market-oriented institutions paired with government stability, which means that, you know, people sort of know what this country does and why it does it, and it's pretty market-oriented. So that's there. And then there are some of these others which I'm going to let you explore by yourself, right? So now with this data set, let me just kind of explain to you some of, you know, the machine learning process that we're going to use. So we're going to divide the data into training and a test sample. Now, in the training sample, we're going to train the algorithms. And what the algorithms are always trying to do is they're kind of trying to come up with better and better predictors with the lowest possible error rate, right? Because obviously a good prediction is when you're accurate, and accuracy basically means you have less error, right? So that's kind of what it does. So it does that in the training sample. So it does, and then within the training sample, it does it multiple, well, literally, depending on the way you know, 500 times, 1,000 times, 10,000 times. Well, you can program all that kind of stuff. So we, I think, did it for about 2,000 times or something like that. And so, so we figure out, you know, whether a bunch of variables are actually good predictors inside the training sample. But see, here's the thing. That's not good enough to tell us whether it's actually a good predictor or not. Now consider this. You go into a room and you look around, right? You look around the room, and now you know where the shelf is, and now you know where the, you know, the chair is, and you know where the table is. And so you know what? You're not going to stumble into the chair or the table or whatever, right? But if your knowledge is a good predictor, right, you should be able to go into another room and figure out where things are. So if the distribution of objects in a room is actually a good predictor, and you know it, well, when you look at it, you know where they are. But the true test of whether it's actually a good predictor or not is if you go to a different room, and now you're blindfolded, and you can say, oh, that's where the table ought to be, that's where the chair ought to be, because when I looked at this stuff, That's where it all was. So if the room is a good predictor, then you should be able to predict, well, in a room you go in blindfolded, right? Well, guess what? That's the same technique we use. So if you find the good predictors within the training data set, those predictors should also be able to predict accurately within data it has never seen before. That's called validation. So that's our test of whether our model is good or not. And our goal is to find the best predictive model. So I'm going to stop part 2 right now and get ready, get a cup of coffee or something. We're going to get ready for part 3.